Hello, welcome to a video about inheritance. What is inheritance? Well, it's a word that means something, and you've run into this word before. In the context of object-oriented programming, what inheritance means is that we can make classes that inherit from other classes. It allows us to determine a kind of relationship between classes. So we can inherit the properties and methods from one class. They can be inherited to another class. This does a couple of things. It has real organizational power because it enables us to define relationships between classes. So that just kind of cements the structure of our programming in a really helpful way. And the other thing, just much more practically, that it allows us to do is it allows us to write more efficient code, less repetition, which, as you know, is always something that we're kind of looking for in our programming. So let's get to an example, because that's always kind of going to be the best way for us to think about this, right? And what I'm going to do is I'm going to make a very simple traffic simulation, okay? And the first step that I'm going to take in making a traffic simulation is I'm going to define a class. I'm going to define a car class because, you know, cars are the ultimate in traffic, right? And that's often something that I find myself doing is when I'm starting a program, often the first thing I'll end up doing is defining a class that I want to exist in my program. Because that kind of gives me a tangible sense of what's going to be there. So let's define a car class. I'm going to go to my JS folder. I'm going to select New File, and I'm going to call it car.js, car with a capital C there. And always a good idea to at least get in the basic class structure before you do anything else. So class car, and then my block of code here. And then very early on, though, whenever you define a class, it's a really good idea to remember to put the tag here in your script file, right? So I'll duplicate the script line here, and I will tell it to include my car.js file. So it goes before the script here, as in above the script, because the script is going to use the car, so it needs to come before the script. Okay, so then we're ready to start defining our car class, and we're just gonna keep this simple, okay? Because what we want to focus in on is this idea of inheritance. But nonetheless, this is an opportunity to write some object-oriented code. So we need to have a constructor. We always do when we define classes. And I'm going to have an X and a Y parameter for my car, so I can tell a car where it should start. And therefore, I'm going to have X and Y properties that I will start off with the values passed through into the constructor. So what else am I going to need to know about a car? I'm just going to represent my car as a rectangle. So I'm going to need a width and a height. I'm going to say that a car is what? 50 wide and 20 high. It doesn't really matter, obviously. You can do more fancy stuff if you want to. If the car is going to move, it's also going to need a velocity. I'm again going to kind of short circuit things a little bit. I would write this differently if I was trying to write a really good program and not an example program. So it's going to have a velocity of 5. So it's going to move 5 pixels per frame to the right. And it won't have a y velocity. Even though it doesn't have a y velocity, it's always best. If you're going to have an x velocity, you might as well have the y as well. So that's my constructor that sets up the properties of a car. The other things it's going to need to do, well, it's going to need to be able to move. So I'm going to write a move method. And I'm going to do just the classic thing, which is I'm going to add the velocity to the position. That's all I'm going to do in there. That's what it means to move. Because I want my simulation to kind of keep going, I'm also going to have a method that causes my car to wrap around the edge of the screen when it reaches the right-hand side. So if this.x, the position of my car, is larger than the width of the canvas, i.e. it's gone off the right-hand side, then I'm going to reset the x. There's a couple of ways of doing this. I could just set it to 0, so it kind of teleports back to exactly the left-hand edge of the canvas. What I often like to do, though, is subtract the width of the canvas from its current position. That leads to ever so slightly more accurate-looking results. But both of those are completely fine. Finally, I'm going to display my car. Always put that inside push and pop. That's just a good thing to do. And now what? I'm going to use rect mode center. It's just a preference of mine. A lot of these things are just about preference. I'm going to have no stroke. My car is going to be red. And as I said, my car is just going to be a rectangle. So I'm just going to draw it at the position of my car, which is its X and Y properties, and with the dimensions of my car, its width and height properties. And that's it. That's a car. Didn't take long. And who knew? I mean, Toyota should get in touch with me. I'm so good at this. Admittedly, my car can only drive to the right, which is a disadvantage. But it can teleport, so that's I'm going to stop talking about that. So we've got the basics of a car, and it's included in our index.html. At this point, as a programmer, I would want to now make sure that this car does something. So I need to add stuff to my script. And because I probably want more than one car, I'm going to have a cars array. I tend to name my array variables in the plural, so cars, because they're going to have more than one car in them, right? They're going to have more than one thing in them. I'm going to have a variable to tell me how many cars. I'm going to have 10. And then I need to do the standard setup of creating a canvas. But to populate my array, to put things inside this array here, which starts out empty, I'm going to need a for loop. And I'm going to need to count from 0. Oh, see, I forgot my let there. Let I is assigned 0. I'm going to count up to num cars. So for as long as I is less than num cars, I keep going. I goes up by 1 each time. Now, I'm just going to put my car in a random place because that's sort of the easiest here. So let x is assigned a random number 0 to width. And same thing for y. Watch me type. And then I'm going to make my car, right? So I need a variable to put it in. So I'm going to say let car. That's going to be my temporary variable to store the car in. And I'm going to make a new car. And we know that this is calling the constructor of my car. So we know that we have to give it a position, which is going to be my x and y variables there. So a random position on x and y. Finally, I need to push my new car into the cars array. So cars.push car. Okay, so that makes me 10 cars. Then in draw, I need to use them. And this requires another for loop, right? Same kind of for loop, start I at 0. This time I'm going to count up to cars, the array dot length, because the array knows how long it is, and that's always better to rely on. And I'm going to do the same sort of idea. I'm going to get cat. I want a cat. I'm going to get a car out of the array at the current index position. So I is the current index. So I'm going to say, give me the current car, and we'll store it in this variable. This is just to make the loop more readable. I just prefer doing it this way. And then that car that I just pulled out, I'm going to move it by calling its move method. I'm going to wrap it by calling its wrap method. And I'm going to display it by calling its display method. Okay? And then we have a little program that makes 10 cars and moves, wraps, and displays those 10 cars in draw, as well as filling in the background. So we should be able to run this now. Let me run it. Good, that was lucky. So we can see these rectangles, they're moving across the screen left to right, and they're wrapping back around when they hit the right-hand edge, which is what I wanted. You can probably see that there are aspects of this simulation that could be improved. The cars look stupid because they're just rectangles. You only know they're cars because I keep saying the word car. It's quite possible, there you go, these ones here, for example, are overlapping. That's silly. I would want to avoid that if this was a real simulation. I would want them to be able to do all kinds of stuff, but we don't have time for that because we want to focus on something else today. So let's return. Just having cars is boring. It's not the only kind of traffic, and I want a more sort of full-bodied simulation, if that's the correct word. Definitely it is not, but we've used it now. The more full-bodied simulation would have other kinds of things in it, right? So let's say that I want a motorcycle. And let's say that a motorcycle is going to be very similar to a car. You can tell it's going to do a lot of similar things, but it's going to be smaller, so its width and height are going to need to be different. And it's going to be faster, so it needs a different velocity, and I'll make it a different color. So I'll need to change this as well. However, most of the stuff that I'm going to do in a motorcycle is kind of going to be the same as this. So with that in mind, let me make a new file. New file. I'm going to call it motorcycle.js because that's the name that I'm going to use for this class. And I'm going to write class motorcycle with my block of code. Now, I could start typing it all in here, but I suspect what you would do and what I will do right now is you're just going to copy and paste, right? Because we know that basically everything in car is exactly what we're going to want for our motorcycle. So I'm just going to actually copy everything, constructor, move, wrap, and display. And I'm going to paste them over here in motorcycle, and then I'm going to make the changes that I need, right? So in the constructor, the width I'm going to make 30, and the height I'm going to make 10, so it's kind of skinnier and smaller. That will cause it to look different. Its velocity I'm going to make higher, so it moves faster than the car, twice as fast. Move doesn't need to change because that's just standard. Wrap doesn't need to change because that's also just standard. Display is almost all the same, but I'll change the color. So instead of being red, I'm going to make it yellow. Okay. And that was it, right? So you can see I just cut and pasted the car, copied and pasted the car, and efficiently went through and changed a few things. That would be a very natural way of doing things. This is actually, this idea of this copy and paste is the subject of today. But for now, let's just integrate our motorcycle and carry on. So remember, always need to include it in index.html. So let me do that. Motorcycle. There we go. And I need to put stuff in the script, obviously, to make the motorcycles come into existence. So there's going to be a bit more repetition here as well. Motorcycles, empty array to start with, num motorcycles. I'll make that 10 as well. Then I'm going to need another for loop that is very similar to this one. Oh. I is less than num motorcycles, I plus plus. I mean, this is very similar, isn't it? I could have copied and pasted this, but for some reason I thought it would be more noble if I typed it out. I'm really doubting that that was the case now. Is new motorcycle at X and Y. And then finally I'm going to add that into the array. Okay, so then I've created my 10 motorcycles, right? And then again, I'm going to need to do this stuff again. This time I will copy and paste it just for fun. So again, with the motorcycle, because it also needs to move, wrap, and display, I'm going to need to do the same kind of thing, right? Instead of cars for this loop, I'm going to apply it to motorcycles. And instead of a car variable, I should really have a motorcycle variable to keep consistent with my naming. So now we've got an array that goes through all of the motorcycles, and for each one moves, wraps, and displays. We've got our motorcycle class, which is the same as the car class, except with a couple of different properties in there, and we've included our motorcycle class inside the index.html before script, because the script uses it. So let's go check that out. There we go. So that worked. Quite satisfying. Oh, these ones are writing very nicely in formation here, these four. We've got our motorcycles. They're moving faster. They're littler. They're yellow. And then we've got our cars moving sedately along as well. It's not the world's best traffic simulation, but it's good enough for our purposes here. Okay? Lots of stuff I would add if I could. So let's return to what we were talking about when we copied and pasted car. And I can illustrate this reasonably well just by switching backwards and forwards between these two tabs, actually. Oh, let me just delete this just so it's even more obvious. So there you go. So I can switch from car to motorcycle, car, motorcycle, car, motorcycle. And you can see that almost nothing is changing, right? These two classes, and you would expect this because this is a copy and a paste, they have almost all the same code, except that they have different widths and heights, a different VX, and a different fill color. And apart from that, they're identical. And that's not great, right? They're really, really similar. The constructor is basically the same thing. Move and wrap are identical. They don't change at all. And display is really, really similar too. So if they're really similar, we could ask, why is that? And one answer is that we copied and pasted car. That's fair. But the real reason that they're similar to each other is that they're the same kind of thing, right? That's why they've ended up being similar in my simulation, is that cars and motorcycles are both vehicles. They're both a kind of vehicle, and a vehicle is the thing that has the sort of all of those shared properties and methods or sort of abilities that the car and the motorcycle have. Those are things that come from the idea that they are vehicles. The fact that they have a position, the fact that they have dimensions, the fact that they can move, the fact that they can wrap back around the screen. These are all things that are common to a vehicle in our simulation. And the car and the motorcycle are just specific versions of a vehicle, right? So what we want to be able to do, given that we know this, and we may well want to create other things like trucks or whatever, trucks, skateboards, who knows, people on roller skates. What we want to be able to do is sort of define what a vehicle is so that we can collect all of this common code into one place. And that is exactly what inheritance is for, okay? In object-oriented programming, inheritance allows us to define a class, like vehicle, that other classes, like car and motorcycle, inherit from. They can get all of its properties and all of its methods, and then they can make their own specific version of that overall idea, okay? And there's some terminology that we want to pick up here. So in this idea that we're going to be following through on, the vehicle, the thing that both car and motorcycle are a version of, that's called the superclass, or sometimes it's called the parent class, because it's kind of the one up on top in the hierarchy. The car and the motorcycle classes that would inherit from the vehicle class, they're called the subclasses, or sometimes they're called the child classes, because they inherit from it, right? And another piece of language that we use along with inheritance, so we might say that the car inherits from the vehicle, all of the vehicle things the car inherits plus its own extra new stuff. We also often say that the car extends the vehicle class, right? It is the vehicle class plus extra stuff, okay? And of course, there is some new syntax, there's a slightly new way of writing things so that we can use this idea in our actual code, not just conceptually. So the first thing that we're going to need to do if we want to use inheritance is we need that vehicle class, right? So let's make our vehicle class. We've already got kind of all of the pieces that we need for this. We just need to put them together. So let's make a new file in our JavaScript folder. We'll call it vehicle.js. This is going to be our superclass, the thing that our other classes are going to inherit from. So it's just got the regular name. We do need to make sure that we include it in our list of scripts in index.html. Now, because both car and motorcycle are going to need to know about the vehicle, because they are both kinds of vehicles, vehicle should be at the top. Vehicle should be before car and motorcycle because they need to know about the vehicle. Just like script, it needs all of its classes to be before it so that script knows about these classes. Car and motorcycle need to be after vehicle so that they can access the description of what a vehicle is. Okay, so what is a vehicle? Well, we've already got the answer to this, right? It's all of the common stuff in car and motorcycle. All of these things that don't change are things that ideally we would put into the vehicle class. We may or may not be able to do all of that, but we can do a damn good try, okay? So the constructor, for example, I'm just going to copy the car constructor. The vehicle is going to be constructed in a very similar way. It's still going to have an X and a Y. So a vehicle has a position that we tell it in the constructor. But a vehicle, because it's the abstract superclass, right? We're not going to make an actual vehicle. We're not going to make a new vehicle in our script. We're only going to use the vehicle to define what a car and a motorcycle are by extension. So in fact, its width is not going to be 50 or something. It's going to be undefined is what we're going to say. It's undefined. We don't know what the width and height of just a standard vehicle is. And its Vx is not going to be a specific number because the vehicle doesn't need to move. We're just going to set it to 0. So it doesn't have a velocity. It knows about velocity, but it doesn't have one. It knows about width and height, but it doesn't have a width and a height. It knows about the position, and it gets those through the parameters. Okay, so that is the constructor. Going back to car and looking what else is common. Well, move and wrap are common, right? They stay the same between car and motorcycle completely, so they should certainly be something that a vehicle does because it's in common with all vehicles. So all vehicles move according to their velocity, and all vehicles can wrap on the screen according to their X position. The final thing in both car and motorcycle is the display method, right? Now, there are ways to make this display method much more fully in the vehicle. But for simplicity, all I'm going to do here is I'm going to have an empty display method in vehicle. Define this in the subclasses. So one thing that we often do in object-oriented programming with a superclass like vehicle is that we will define a method like display here, but we won't put anything in it. And the reason that we do that is to remind ourselves or anyone else who's using this class, you need to have this method in your subclass. All vehicles should be displayed, but the general idea of a vehicle doesn't have this idea. It doesn't have a specific display method that actually does something. This is kind of a placeholder to remind you that displaying is something that vehicles do, and then the car and the motorcycle can take care of the specifics of how they should be displayed, especially if they've got like really fancy display approaches. Okay, so now we've got a vehicle. this class on its own doesn't really do anything. For instance, it doesn't even have a width and a height, right? But it defines the commonalities between all vehicles. Cars are like this, but they have a specific width and height and velocity and way of displaying, and motorcycles are like this, but they have a different width and height and velocity and way of displaying. And we can use that information to simplify our definitions of car and vehicle now, okay? So let's go do that. So let's return to car now that we've got this idea of a vehicle. So the first thing is, how do I say that a car is a kind of vehicle? So we need some way to say that so that JavaScript knows that's what I want to do. And the way that we do that is we use the special word extends. That's why I mentioned it earlier. So we add that right at the beginning. So when we say we have a class called car, because it's a kind of vehicle, it extends the vehicle, it inherits from the vehicle, we write extends vehicle. That way JavaScript knows that it can go and look up particular properties and methods in the vehicle class if it needs to. Now, the constructor can be quite different now. In particular, this is already being done inside the vehicle constructor, setting the position. And this is also already being done. The only specifics really of a car are these three things here, right? Setting a specific width, height, and x velocity. So I'm going to delete these other ones. So then my car is only doing the specific three things that are particular about a car. However, I still need to tell JavaScript that it should set up my car like a vehicle. And to do that, I need to call the constructor of the vehicle, because I still want all of this stuff here in the vehicles constructor. I still want all of this to happen, right? I still want all of these properties to exist, and I want them to have their default values that I can then change for my car. So to tell JavaScript from inside the car class that I want to call the vehicle constructor, you might think that you would write something like this, right? Call the vehicle constructor like this. Which is kind of what we do in the main script when we call these constructors, but it's not what we do here. As I was saying, the vehicle is the superclass to the car. The car is the subclass of the vehicle. So if we want to call the superclasses constructor, we actually write the word super. That's how we call the constructor, super. So that's saying call the superclasses constructor, which is the one in vehicle, and give it these x, y parameters that came through into the car constructor. So this will go away and run the vehicles constructor. It'll set up all of the properties, and then in the specific car class here, we're going to set the particular width and height and horizontal velocity that a car has. Okay? So set it up as a standard vehicle and then add in our car stuff afterwards. This is the standard way that we write a constructor once we're using inheritance. We always call the super constructor first, and then we set up any of the specifics for this specific class at that point. Now it gets nice. The move method, which the car has, is the same one as the vehicles one, right? So we don't need this because the vehicle already takes care of this move method. So a car can already move because it's a vehicle, and a vehicle can move. And we don't want to do anything special there. Likewise, the vehicle takes care of wrapping, so we don't need our car to know how to wrap either, because the vehicle will do that. The display method, we'll leave it as it is, right? Because remember, in vehicle, although we defined a display method here, we said that the subclass should be the one to actually determine all of the ins and outs of how to be displayed. So there's nothing in here, so we can't rely on what's in the vehicles one to do something. So the car will keep its display method. But we've vastly simplified the car class now because it extends the vehicle. We don't need to set up all the properties, just the ones that this car makes particular use of. And then we make sure that we call the superclasses constructor so that it gets all of the vehicle stuff for free. We didn't need the move or wrap methods because the vehicle already has those. And then we have our special custom display method for displaying a car. So we've made that code significantly more efficient. We've removed things that were repetitive, and we can do exactly the same thing here for the motorcycle. We make sure that we call the super class constructor by saying super with our parentheses and the arguments that we want to pass through. And then we just make sure to set any of the properties that a motorcycle has in particular, such as a specific width, height, and velocity. And again, we don't need move or wrap because the vehicle knows how to do that. The vehicle part of the motorcycle. Oh, but I forgot a very important thing, which is I have to say motorcycle extends vehicle. This is how JavaScript will know that a motorcycle is a kind of vehicle, and that's what gives it all of those special powers. Okay? So we've improved both car and motorcycle now by removing code, really, because of that vehicle class definition. And this becomes more and more powerful the more of these subclasses we create, right? If I then also create truck and I create Segway or whatever it is that I'm going to add, I only need to define the things that are specific to a truck or a Segway, just like I did with car and motorcycle, and so I avoid a lot of this repetitive coding. Another nice thing that you may have been wondering about is I don't actually need to change anything in my script. I'm still making cars and I'm still making motorcycles and I'm still calling move, wrap, and display on them. It's just that now we know that a car is a kind of vehicle behind the scenes, right? It's just behind the scenes. The script doesn't even need to know about this. It's just the way that we've defined what a car is and what a motorcycle is. What this means, though, which is kind of neat, is that now when we call car.move and car.wrap, we know that the car class itself doesn't even define these two methods. These aren't even in there, right? In car, they're not there. There's only the constructor and display. But we can still ask a car to call the move and wrap methods because it is a vehicle, and so it will just use the vehicle versions of those methods when it doesn't find one in a car. Same thing for the motorcycle. And then display is different, right? That is defined inside the car, and so that will use the car version of display. So it's kind of a beautiful thing. It's all about being organized, but also it's all about kind of understanding how your program works in this kind of much more sophisticated way that allows you to, again, keep thinking about programs in terms of objects and relationships and kind of a world that you're creating, right? And that can be hugely advantageous as we work on more and more complicated programs. So that is the wonderful world of inheritance, at least the beginning of it. And I think you can already see how this is going to be convenient in terms of avoiding repetition and being able to think about classes in relation to each other. So that's it for now. We will continue on, obviously, in this topic for a while to learn all of the ins and outs, but that's the basics of it. We can extend classes as a way to gain efficiency and a better way of thinking about how our program works. See you in the next video.